Okay, so hello, I'm Vincent. I'm a professor at the University of Maine, and that's a picture of me. It's not far from there, though. That's a couple weeks ago with the foliage looking nice. So, in case my research areas, it would be nice if my full-time job was writing demos and stuff, but actually it's high-performance computing and embedded systems work and some performance counters, hard performance counters, Raspberry Pi stuff, and that's some projects that work on the side. You can notice that the first one there is a Raspberry Pi supercomputer. The second one is a Raspberry Pi chiptune player that's got some AY38910 chips in it, and you can play chiptunes on it. And the last one, I built some time circuits controlled by the Raspberry Pi and a flux capacitor for time travel purposes and all that. But we're here today is to talk to you about the Apple II. So that's me, undisclosed number of years ago, using an Apple II. And so some history on the Apple II. And why don't you see very many Apple II demos out there? And there was probably various reasons. One is the cost. Back in the day, Apple II was actually sort of a pricey computer. It's not widely found in Europe, in France a little bit, but not so much other places. You're going to see in this talk it's got fairly boring sound and graphics capabilities. It's a pain to program. And also, if you wanted to present at a demo in Europe with your 60 hertz Apple II, you'd have to drag it over there with you, and it's probably a pain to do that. So some history. So does everyone know who those two guys are? So that's Steve Wozniak and Steve Jobs there. And so Apple Computer was founded in '76. Their first computer, the Apple I, you don't hear much about. It's because when they finally came out with the Apple II, they recalled all the old Apple Is, and so you probably see them in the news. They go for auction for a decent amount of money. But the Apple II was introduced in 1977. Not 1979, like the slide said last night, 77. So it's just ever so slightly older than me. So various models they had. The Apple II original came out in 77. The Apple II Plus came out in 79. And the big difference with that was they moved to the floating point version of BASIC. Originally, they ran integer BASIC by Wozniak. And actually, the AppleSoft BASIC they ran, it was actually made by Microsoft. And a lot of people don't know that. But I'm not a big fan of Microsoft, but they actually did an OK job of 8-bit basics. I'll give them that. The Apple IIe came out in '83. There was an Apple III, believe it or not, that was supposed to be a business machine. It came out right about the same time as the IBM. Horrible hardware problems for various reasons. So it failed, but they took some of the stuff they learned from that, put it into the Apple II line, so the Apple IIe. Apple IIe had up to 128K of RAM. They reduced the chips. They added lowercase. Before that, all the Apple IIs only had uppercase. They introduced 80-column cards for getting 80 columns of graphics at times instead of 40. And they actually introduced some other impressive stuff, like double high-res graphics, where you got better graphics. In '84, they introduced the Apple IIc, which was portable. By portable, I mean they more or less took an Apple II and they stuck a handle on it. And Apple II GS came out even later. That was their 16-bit competitor that came out. The GS stood for graphics and sound, and it actually was trying to be competitive, with the Amiga and the Atari ST and that type of stuff. And that's a much different machine. I'm not going to be talking much about those today, but they actually had their own sort of demo scene for them with much better graphics and all that. And so Apple II Forever, there's actually an ad campaign from Apple called Apple II Forever, and it was sort of very creepy. You can look it up online on YouTube, and it's a creepy video. So Apple's like, yes, the Apple II line will last forever. And then very soon after that, they canceled the whole thing in 1993. And they killed it for the Mac. Jobs hated that the Apple II was actually funding the Mac because the Apple II was popular and the Mac was slow to take off and all that. So even though the Apple II was still outselling it. So the Apple II was designed by Steve Wozniak. He had made the Apple I. The Apple II was his follow-up. And the big thing he wanted to do, actually, was he and Jobs invented Breakout, the video game, in hardware at Atari, and they wanted to make it in software in their own machines. So he decided he wanted a machine to impress his friends at the Homebrew Computing Club, and so he made one with sound and graphics and all that. And Woz's incredible machine, incredible optimizations at the gate level. He spent all this time. He'd just say, this is why I can gate too many. He'd optimize it, try to get rid of all the gates and all that to make the design smaller. And this is one of the last designs designed entirely by one person. It was almost entirely designed by him. And so what it looks like inside, so it's actually a very simple design. It's got a 6502 CPU. The original version only had 4K of RAM. At the time, you could actually install 48K of RAM in 1977, but it would cost you a heck of a lot of money, so not many people did that originally. And the rest of the inside, if you look inside an original Apple II, it's mostly just 7400 series logic, several 555 timers, and 741 op amps, very basic type stuff. That one diagram, you can't really see the circuit diagram, but it's showing that the cursor blinking. So if you fire it up and the cursor blinking, it's actually a 555 timer that's triggering the cursor blinking in hardware. It's not, in software like most mid-80 machines. One nice thing about it had all these expansion ports, so it has a bunch of expansion ports inside, and it came with the full schematics and the full ROM listings. So it was very open. Because of Wozniak's influence, is very open design, very unlike, sort of how Apple is today, really. So storage, originally, you had to do everything by cassette tape. Later, in 1980, Steve Wozniak put together the 5.25-inch disk drive. And eventually, you could get up to 140K per side. They were single-sided floppies, like this. And the disk drive, the disk 2, invented by Wozniak, there's some interesting story behind it, but originally, the drives back then had a lot of hardware on it, but he thought it was too much hardware. So he came up with all these ways to cut down the hardware to try to make it a cheaper drive. So, for example, it doesn't have a track 0 sensor. So if you want to find where track 0 is, what can you do if you don't have a sensor? Well, there's only 35 tracks total. So what it does, it keeps seeking as much as it can until it hits the end and then slams against the side. So if you boot up an Apple II with a disk in, you'll hear this like chuttering noise, like da-da-da-da-da. It's like the head hitting the side and slamming into it, trying to find track 0. The other story about all this is they went to Shugart, the company made the disks, and they said, we want a cheap and cut down version of this disk drive so we can use it. And so they sent them some, and Apple found it, and they found they were really hard to get working, so they eventually got it working. They went back, yeah, it'll work, give us a whole bunch of them. And they were shocked. What they did, they thought Apple wouldn't do this, so they gave them defective drives in the hope that they'd say, oh, we can't do this, and buy the full price ones. But they got so good at doing it, they got the stripped down ones and all that. So it's a faster disk drive, but it's sort of a hard real-time thing. Like when you control it, you actually control the stepper motors directly. And this means you can do some amazing things. And the people who did copy protection in the games back then would do amazing things where they would step the drives, quarter tracks, and all kinds of crazy stuff. And if you're interested in that kind of stuff, there's a guy in Twitter, Apple II 4AM, you can look it up, and they're trying to preserve all the old games, and they can't because of the copy protection. So they're having to break all the old copy protections, and sort of a fascinating thing. So 6502, you've probably seen it before. So originally, it was sort of cheaper than all the competitors at the time. And so it's 8-bit. The highest number you can get is 255. You can get 64K of address space if you don't do bank switching. It only has 3 registers, the accumulator X and Y, and there's weird limits. You can increment and decrement X and Y, but you can't in the A. All the math goes on in the A register. The 0 page, the first 256 bytes of RAM are faster than the rest. Your stack is limited to 256 bytes at page 1. That's all you get. And new main connection, I teach at University of Maine. It turns out Chuck Peddle, the guy who co-invented the 6502, he actually went there. And actually, everyone had forgotten this. I found this out just going on Wikipedia. And I'm like, everyone, did you know that Chuck Peddle went here? And they're like, oh, no, who's that? And stuff. So we're finally hopefully getting him recognized. I think they should build a cool 6502 statue on campus or something, but it's not happening yet. And the 6502 is sort of an understandable chip. People have gone at the transistor level and built a 6502 out of raw transistors, and it doesn't run fast enough to run your Apple II, but you can get that, so it's pretty cool. So the memory map of the Apple II, just briefly, it's got graphics pages inside of memory, and you can use them for graphics. You can also use them for RAM, but if you use them for RAM, all the graphics are torn, it doesn't get garbage on it. And Apple DOS takes up some room, but you can get rid of that, and basics in the high memory. And then a language card, I won't mention this, but as an expansion for the original Apple IIs to give you the full 64K of memory by swapping out the ROM for the RAM. So graphic features, this is why people often make fun of the Apple II, especially Commodore 64 people. So what does it not have? It has no hardware sprites, no palettes, no V blank, H blank interrupts or registers to see when that happens, no hardware scrolling, no programmable character set, no programmable timer, nothing good. And you might say, what does it have? Well, you can do sort of hardware page flipping between 2 graphics pages, and that's about the most advanced thing you can do with it. So the various graphics modes, text mode. So you can see an example here, that's Zork. That's 40 column, and this is 80 column if you later get an optional 80 column mode. So you get 40 by 24 graphics. You can have invert the text, black and white. You can make it flash. You get 2 pages of them. Each takes about 1K, one at 400, 1-800 hex, that $sign in 6502, usually that means hexadecimal. Uppercase only original, lowercase and 80 columns didn't come till later. And there's a color killer circuit, so it's doing NTSC composite, and so with the text you're only doing text mode, it'll kill the color signal to give you a much clearer signal. But if you have graphics going on, it'll turn the color on, and you'll get weird green and purple fringes to your letters that you'll see. Another mode it has is low-res graphics. So you get 40 by 48, and it's the same memory as text mode. It's just instead of interpreting as ASCII characters, it takes 4 bits at the top, 4 bits at the bottom, and makes a 16-bit color. You actually only get 15-bit colors because two color grays, but they're exactly the same. So you get 2 grays. And you can optionally swap in the bottom 4 lines of text. And so on the left there is a basic game called Lemonade Stand. It's sort of interesting to play if you ever play it. And this one on the right is one I'll talk about later, a demo I did. High-res graphics, so high-res, in quotes, 280 by 192. In actuality, it's only really 140 by 192 due to the limitations. You get 6 colors. You get black, white, orange, blue, purple, and green. And you optionally also can get the bottom 4 lines of text. And each takes 8K. So to the left, that's a Mystery House. That was one of the first graphical games ever released. People, believe it or not, were amazed at the graphics when they came out. On the right here is some more advanced graphics. It turns out educational programs. Apple II is used a lot in schools, so by the end, they had some people with educational games really good at graphics. And right now, you're looking at that and saying, was that really that good graphics? But when I explain some more, maybe it'll come in. Some other examples. Top left there is Lode Runner, a game. Bottom is Prince of Persia. So that was originally written for the Apple II by Jordan Mechner. Upper right, I'm sure you've seen Oregon Trail. And then here are some modern tools. You can actually have some nice modern tools. You can take, regular modern graphics and run through a converter and actually get sort of decently dithered stuff despite only having 6 colors. So problems programming the graphics on the Apple II. It's not a linear frame buffer. It's actually split in chunks of 3. And you say, why did they do that? Well, it's in 40-byte chunks, and to fit in 128 bytes, powers of 2, they sort of did that. That's not the only thing, though. So Wozniak, famous for optimizing things. RAM was expensive, and SRAM was expensive, so he went to use DRAM. And so DRAM, if you know anything about dynamic RAM, you have to constantly refresh it. It's just a capacitor that holds your bits, and over time, they'll just drop down to 0 and leak all the power out. So you have to periodically refresh it. In a lot of older systems, they'd have special circuitry to refresh it, and often it would slow down your machine because they had to stop the refresh and come back. He noticed the 6502 in the clock cycle. One clock cycle it accesses memory, other clock cycle it doesn't. So he realized if I can use the video to access the RAM during the other clock cycle, and if I scattered the addresses enough so that I just happened when I refreshed the video to access every graphics page, every memory page, you can refresh the memory for free. So that's what he did. He set it up so the DRAM refresh happens completely for free by the video drawing code, but it means your graphics are just scattered all over memory, and it's sort of a pain. So like at the bottom here is a lookup table you use when doing low-res graphics, and you see that it starts at hex 400, and it sort of counts up, but then it counts back to the beginning again, and it's jumping all around. So it means anytime you do graphics, you either have to have a lookup table or some complicated equation to find where on the screen you should be. High-res graphics is even worse. It's got the same stuff I mentioned before, but again, it's a hack. So you have 8 bits, and 2 bits of those specify a color. But you can only specify the top or the bottom colors. So in your 7-pixel block that's specified 8 bits, you can either have orange or blue or purple-green, but you can't have them both at the same time. The other thing is when you do the colors, if you have 2 consecutive 0 bits, that's black, always black. If you have 2 consecutive 1s, it's always white. And so that means if you have a pattern of colors, 0, 1 meaning like orange and 1, 0 meaning blue, but you have them next to each other where they transition and you have the 1, 1 there, it makes a white fringe. So the top is just sort of an example that you can't have certain colors next to each other, and sometimes when you have 2 colors next to each other, it'll have a black or white fringe on things. And so it's really hard to get good-looking graphics. So that explains why these graphics might be better than you think, and that's because you notice that the colors are in blocks of 7, so they don't, have that problems. You see the edges have black and white in strategic places to hide the problems. And so getting good high-res graphics on the Apple II looking nice, is actually a bit of a pain. Later on, they came out better stuff. So the Apple IIe and later, they had what's called double high-res, and in that one, you could get, you needed 80 column card plus 128K of RAM. With that, you could get 140 by 192 in 15 colors, and you can get double high-res 80 by 48. This is even more of a pain if you can imagine that, because you had to switch the banks while drawing. Half the bits were in the one bank, one in the other, and so it was even almost more of a pain to do those. I won't be talking much about those because it's sort of later on. So music and sound on the Apple, originally all you get is a 1-bit beeper type thing. That's all you had. And there's no timer, so you can't set up a timer, so you more or less have to bit bang the speaker to get anything out. And some people did some amazing things. There's something called Electric Duet, where it lets you some code that you can get 2-channel sound sort of out of it, and it sounds more or less okay, but that's all you can do. Your CPU is entirely spent doing that. Some people also wrote some sample code, so you can get nice voice samples and all that, but in general, it'll take up like over half your RAM, and like there's some games where they famously have scream sound effects and all that, but like half the RAM would just be the samples for the sound. They had some add-on boards. The most popular was called the Mockingbird. And what this is actually two AY38910 chips on a board in there, so similar to the ones on ZX81 or ZX81. Maine is close to Canada, so the Z people got to me too. So you can get ZX81 and ST-style chip tunes on it. So it's 3 channels of square waves of noise and envelopes and all that. And so there were some games that had this. This card came out in '81, and people used it, but it was actually sort of obscure. So you got a handful of games that used it, and there's probably actually been more software released in the last 5 years that uses the board than actually was released at the time. So the question is, so now that I showed you how hard this all is, what can you do with all this? And can you write a demo for this? And it's how I've been wasting the last few years of my life here. So this all started out, I've been doing Apple development. As a kid, we had an Apple II, and I did some work on it. I have disks and disks full of basic programs that are full of crazy basic programs. And I worked on it some. And then recently, meaning about 5 years ago or something recently, I started going back with AppleSoft and trying to redo some games. I guess these days it's called demaking, where you try to take a game and make it an old platform. And so when I did Kerbal Space Program, and you can actually get a surprisingly playable 2D Kerbal Space Program in AppleSoft Basic. And then my 5 minutes of fame, I had played Portal for the first time really late in the game for some reason, so I made a very simple version of Portal in it, and it's playable and in Basic. And it made the front page of Hacker News and the Register, the British website. They interviewed me and all that. And you get to the end, and it plays still live, just like the real game. There's actually only like 2 levels of it. It looks like there's more of it, but it's playable though. And I said, boy, this music sounds horrible. How can I get better music out of this? And so that's when I went down and what can I do with this type of stuff? And so I eventually tried looking into getting a Mockingbird, but then they make reproduction ones, but it took over a year for it to get there. And that's why I made my Raspberry Pi one, so I could mess around with it in the meantime. And so I ended up figuring out how to get some old ZX81 style chiptune music playing, and so I released a music disc that will play the old music and all that. And also, I was looking into things, and somehow I came across the demo scene stuff. And so there's a group called French Touch, and they actually have some pretty amazing demos. And if I have time, I might show one or something like that. They're actually a little better than the ones I make. Sadly, they sort of gave up a few years ago. They're like, well, we're done doing this now, and so they went away. But you go to their YouTube channel, and they have some actually really impressive demos of the Apple II. Their main difference, I try to focus on the older machines, the original from 1977 type machines. They focus on the more modern ones of 128K and sometimes the fancier graphics and all that. So this first demo came with, I wasn't actually intending to make a demo. I was actually working on a Final Fantasy sort of looking game just for various reasons. And I made some code, and I realized I was getting close to something that was similar to a demo, and I ended up turning it into a demo. And if you want to write up on this, the Hacker magazine, the Proof of Concept, or GTFO, the most recent one, they have an article published on it. So I was going to, if all goes well, I'm going to try to run it real quick here.
Put this on the projector?
Yeah, put that in the projector and see if that will work. It should be self-running, I think. Is it going? Yeah. Okay. So all this looks pretty blocky, but it's actually impressive if you're an Apple II person. Thanks. So press the right button there. So yeah, so I'll just briefly mention a few things on, press the right button, out there. 2. Yep, so yeah, the flying scene, it's called Mode 7 Demo, so you know anything about Mode 7 on the Super Nintendo, that's the mode where you squish things down and you get sort of like the Final Fantasy games, you're flying over the surface and all that, so that's where it came from. And getting this to work on the Apple II was a bit of a pain, so there's a lot of self-modifying code, a lot of table lookups. I managed to reduce the whole thing to 7 multiplies, but multiplies are horribly, horribly slow. The 6502 has no multiply, and to do this, you need 32-bit by 32-bit multiply, which is even slower, so to 16.16 fixed point and all that. The one trick you can use is a neat mathematical thing where if you take these formulas and work it out, you can actually change a multiply into a sum of squares minus difference of squares divided by 4. So what that means is you can change a multiply into 2 table lookups of tables of squares and then a shift left, and you get it much faster. So if you're willing to dedicate 2K of RAM to these lookup tables, you can get your multiplies, a lot faster. And so that's how it gets it. And so the frame rate it gets for the flying thing, you actually play that in a game. It's not just, some people say, is that pre-rendered? No, it's done on the fly. You can get about 10, 20 frames a second, depending on what you're doing. The sound slows it down a bit. And so that was the one thing I was working on. So again, if you look at it, there's a paper that goes on more about this. So this last thing is what I've been working on sort of more recently here. So this is, again, I'm trying to work in this game, and I keep getting distracted. So I have some cycle counting demos. And so for this to work, what it's working on is if you're racing the beam on the Apple II. So we mentioned you only have those 3 graphics modes, high res, low res, and text. But you can actually switch those modes anytime you want. And there's 192 lines in the screen, and each one is 65 cycles long, 25 in the horizontal blank, and 40 on the screen. And then when you get to the V blank, you have 4,550 till you get to the top again. So if in the middle of the screen you decide to switch from low res to high res mode, the Apple II is fine with that. So you can do things like draw and split things like that. And so the problem with that is you have to know when H blank and V blank are happening. And I mentioned before, you can't know that in the Apple II, or at least not reliably. The Apple IIe, eventually they had to register, but the Apple II GS2 and the IIc, but they're all incompatible the way you do it. But there was a hack, a really crazy hack to get this even the original Apple II. And so this is called sort of vapor lock. So what happens, I mentioned before that the 6502 is doing its thing, and then on the off cycle, the video circuitry is reading the memory. And so what happens is when the video circuitry reads this memory, there's a residual capacitance on the bus. And so that last read sticks around. And so on the CPU side, if you read from an address that's not hooked up to anything, for example, a write-only soft switch, when you read it in, you'll actually get the residual capacitance on the bus will tell you the last value that the memory wrote to the video display. So if you go through there, you can sort of reliably see what the last thing drawn on the screen is. So if you draw a pattern on the screen, and then you read things out continuously, you can sort of find out where the pattern in the screen is, you can find where you are, and then based on that cycle counting immediately from when you find that, you can cycle count and find where you're on the screen. So you can find this, but it's a lot harder than your normal way of a real device that will tell you when these things are. So that's what my code all does, all my cycle counting code. And this is actually not something I invented. This is called vapor lock by some people. It was well known in the 80s, actually. But no one really used it much, partly because it's really hard to do, and partly because Apple would never guarantee this would work. It was never clear that Apple wasn't going to just one day say, oh, that was just some random thing that could happen, and it's not really supported and all that. So to do this, you have to count cycles. So to do this, when you're programming, you have to get your 6502 manual out and know exactly how many cycles every instruction counts. And so that's not too bad. You say, you had the list here. The thing on this list, is the load accumulator instruction. See those pluses on the cycle count thing? If you cross a page boundary, it takes an extra cycle. So your code could be working fine. You insert an instruction, it pushes something just off the edge of a page, and suddenly all your stuff goes crazy because it's taking an extra cycle, and it's a pain too. And there's lots of challenges in that too, and there's other issues, branches and load stores as they're crossing the pages. If you have a newer machine, if a 6.5 CO2, some of the instructions take different amounts of time, especially jump tables. If I have to do a jump table, I usually fake it using an RTS instruction instead of the actual instruction because it takes longer and all that. And I'm going to show a few things here. I'm trying to avoid spoilers because I possibly have submitted something to the demo competition that does this, and so I don't want to give away too much of that. But So this first one is one I did, and I went to Kansas Fest. So you don't know what Kansas Fest is? There's, believe it or not, an Apple II convention every year in Kansas City, and it's been going on for, I think, over 20 years now. So they have it, and I managed to go this time last year. And it's all the people there. They had a big giveaway where people bring in all their old stuff, and then they'd have everyone rush and grab what they want and get to keep it. On the right here at the end, some Atari people come to this because they like it too, and so they had Atari. They were from the Church of Atari trying to convert us all Apple people to Atari and handing out literature and stuff. So actually, that demo, I think unfortunately, let's see if I can do this. I forgot to put it on a floppy, so I'm gonna have to show it in the emulator real quick, and let's see if I can remember.
So you need sound from your laptop?
Yes, I'll need sound if I can do that. You'll notice I'm running, where is this? There we go. You'll notice I'm running Linux here, but I'm running, the best cycle-accurate emulator is AppleWin, so I'm running under Wine here for my development, which is sort of a bit around the thing. So this demo was at K-Fest, the Kansas Fest, and it was a competition they have. We're at Hackfest, where we had to do it there. So I wrote this entire thing in like the 4 days I was there, you know, also attending the conference and all that. So it's a little rough. The music's a little rough. Hopefully it doesn't sound too horrible here. But, and hopefully it catches. Yeah, so, let me see. Is it coming out? Do I have not turned high enough? Oh, there we go. So some music, I got sheet music from an old Mario game for the Game Boy, but this mode is fancy because it's 40 by 96, and you might have remembered that we only have a 40 by 48 mode, and so what it's doing is there's 2 pages of graphics, so every 2 lines it's switching from page 1 to page 2 on the fly, and doing the graphics that way in cycle counting. So it's sort of its own, new graphics mode. I don't know if I can make this full screen. There we go. So it's just scrolling and all this, but it's the kind of thing you can do that, again, Apple II people, they were like in awe of this, like, wow, you can get things like that. So let's see if I can exit full screen mode. It would be bad if I couldn't. I shouldn't have done full screen mode. There we go. Let me just mute it. Yeah, so that's the demo I did there. This other one, I think I can do this one on here real quick. So again, this is another game I was working on. Doing for time here. Okay, so there we go. Caps lock. You notice I used to have underscores in all these file names, then I was using an old Apple II Plus, and it turns out that even though you can display an underscore in an old Apple II, there's no possible way to type it on the keyboard, which I named all my file names of it in it, and then I got to use it in real hardware. I do most of my development using Linux and the cross-compiler and then the emulator, and then I only copy it to the real hardware to test usually. So let's see if this works. So this graphics mode is one where it's flipping and doing the 40 by 96 thing again, the flip. And let's see if this will work. really confusing the videos thing here. Come on, you can do it. So yeah, so this, so it got cut off at the top, I think, but the top is in text mode, and then it's flipping in the high-res mode, and then it's actually flipping to low-res mode, not the edges in the horizontal blank, which is easy, but it's doing it mid-screen in order to have the more colors from the low-res mode on the screen at the same time as like the high-res mode of Saturn like that. And it's actually, it's beginnings of a game, you can't actually do anything useful yet, but it's, again, it's doing a lot of fancy cycle counting, and so it's just a tricky thing to get working. So, again, Apple II people are always, impressed by this because suddenly you won't see any games from back in the day that look like this because, it was not really that possible. So, that, and thanks. And so that was most I wanted to show. All my demos can be downloaded from the website there. Also, the source code's all available. So my GitHub page there, it's actually very inaccurately in GitHub repository, but I've been putting all my Apple II stuff in there. People have been complaining about it, but it's just easier for me, I guess. And that bottom picture is just my later days. I was a really bad ANSI graphics person for my friend's BBS, but I just put it up there just because. So, any questions on anything on Apple II? The Franklin computers, were they cloned Apple II? And the Laser 128, is that what you're listening?
Yeah, I guess I was wondering that. I guess my other question is, as a musician who wants to maybe chip tune for every platform, are there any demos or anything I can submit music to for this platform for either one bits or AY music? Because I have stuff like I have a Vortex tracker which can do AY music and it can do 6 channels in the program class. Is that a possibility? How hard is it to port that music AY over to the Apple II?
So if you have a Mockingbird card and you want to port AY music over, I have tools for doing it. The Mode 7 demo I had, that was actually a YM5 file I found that I converted, and I still have to do a lot of it by hand though, but the playing, getting things in the Mockingbird, if you have music that's in one of the supported formats, it's not horrible. What I've been trying to do recently was, there was a tracker called Vortex Tracker that the ZX81 people use, and I've got about half of a functioning player for that, but I'm still working on trying to get that going. Actually, the thing I submitted, I actually tried to use that and then fell apart, so I'm doing some horrible hack where I'm using, it's complicated, but
So did you use the Vortex tracker was recently updated to 2.5, much better than what was out there before? I don't know if you're up to that.
No, I haven't done it. I haven't looked at it that much. I know for the most music I did, I got someone help me out who was actually an Amiga person, and they made a 3-track Amiga file, and I converted it to Vortex Tracker, and I think they were pretty sad about how it turned out, but they're okay with it in the end. But yeah, if you get it in that file format, you can get it out of the Apple II. I have some demos that actually do the 6 channels, so it does 6 channels in the Mockingbird, and there's 3 channels right-left, it's stereo, and I actually have a player that can do both channels like that, but still, you're right, it's a lot of custom stuff now. It's not like you just drop in the file and run with it. If you do have a YM5 file, that's the kind that's often used for the Atari ST. Usually, it's not that bad to quickly get it up and going into something like that. But yeah, the tools really aren't there, and my Mockingbird has some issues. We still haven't figured out if it's hardware or software, where the sound, if it still has a certain patterns in the sound, it actually glitches, and I haven't figured that out yet. The music disc that I showed the screenshot for, I actually have it, it'll play like a half hour of ZX81 music and all that, but some of them don't sound that great, and it's still sort of unclear, so there's still sort of mysterious stuff. It sounds great in emulator, so something between the hardware and the various emulators, there's something there. So.
You have the same problem with the 1-bit music. Are you able to port, like, I got the ZX Spectrum right here. Are you able to port the beeper tunes from here, if they're in a good format, onto the Apple II? Is there something that's actually play that back because they've got the
Yeah, that's a good question about the I don't know if there is a standard format for the beeper tunes. The one I didn't show it here, but I have a demo that plays still live from Portal, both on the Mockingbird, but then I have it doing what's called the electronic duet. And again, people have made that's a format that's sort of standard for the Apple II. They can play things through it, and there's some software that can create it, but it's like software you have to run on the Apple II, and the format's documented, but again, it's sort of a pain. I actually have a tracker that I wrote that can take 2-channel sound and convert it to that, but it's like a completely...
I think I might have actually used that program.
Okay.
I used your program.
Oh, okay.
Did not get very far, unfortunately. Probably just my fault.
No, my code, I usually throw this together while trying to do something else, and then it's just enough to do what I need to do, and then it's probably not well documented or well supported. So, but if you have any comments or any, let me know. I'd be glad to. Oh, okay. So, any other questions? Yep.
How sensitive is the timing of the cycle counting as far as like if you tried to run it on a 2DS on 1 megahertz node, or if you tried to run it like on a laser 128, what's the likelihood of that?
Okay, that's a good question about the how the timing affects it on the compatible machines and all that. So I do a lot of my testing on the 2E. From what I recall, the 2GS is a pain because I think I mentioned there's 65 cycles for the scan line. I think the 2GS moves it to 64, and so it possibly, I'm guessing, I haven't tried it, but I'm guessing the cycle counting stuff I do won't work on that. It possibly would work on the laser 128 and all those, but from what I also understand, vapor lock doesn't work for them. Whatever reason they're bus, you can't very easily get that. So if you can get the H-blank, find out where you are in that some other way, it'll probably work, I think. But the way they designed the bus is different, so you can't get that. I have an Apple II, and I've been meaning to try these on my Apple II Plus, but my disk drive has gone out on it, and I haven't got a chance to test it. So in theory, I want to say in theory, it'll at least work on the Apple II and the Apple IIes, but I haven't got a chance to test on the Apple II Plus recently because of that. Yes?
Since you work on the HPC systems, have you made any high-performance computing clusters of
So no, I've not made a supercomputer out of Apple IIs. There is somebody, if you go on Usenet, who actually has. He calls it the Apple Crate. I've never seen that, but he gets the motherboards from the old Apple IIs and stacks them up like this high, and they communicate through the enunciator ports and all that, and it's actually pretty impressive. So he has done that. I don't have enough spare boards to do that, but people have, so it's pretty cool to see. So now Raspberry Pi is sort of the low end of clusters I've built. Any other questions? Okay, so our time, so thank you.